to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss 10 questions from S block elements. First question is lithium nitrate on heating gives. Lithium nitrate on heating gives. How do you know that? Lithium, sodium, potassium, rubidium, cesium. So except lithium nitrate, sodium, potassium, rubidium, cesium nitrate can decompose into some metal nitride and oxygen gas, but lithium nitrate only decompose into lithium oxide, nitrogen dioxide and oxygen gas. Lithium nitrate on decomposition it can produce lithium oxide, nitrogen dioxide, oxygen gas. So the correct option is B. So don't confuse lithium oxide Li2O. The formula of lithium oxide is Li2O, not Li2O2. So the option is B. Now coming to second question. Which of the alkali metal chloride forms its dihydrate salt easily? KCl, LiCl, CSCl, RbCl. Given lithium, sodium, potassium, rubidium, cesium. These belongs to first A group elements. They given lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. When we are moving top to bottom, size increasing. So lithium always shows anomalous properties. That's why it only form hydrated salt. But remaining sodium, potassium, rubidium, cesium chloride does not form any hydrated salt. So lithium chloride only form hydrated salt. Hydrated salt means water molecule. It is combined with water molecule. So option is LiCl. Now coming to third question. So which among the following compounds shows the highest lattice energy? Given that LiF, CSF, NEF, KF. Here these blue circles indicates lithium, sodium, potassium, rubidium, cesium. These circles indicates size of fluorine. Here when we observe the LiF, so the size difference between these two ions is very less. When we are moving from LiF to CSF, the size difference is more. If the size difference is more, lattice energy is less. If the size difference is very less, lattice energy is more. So in LiF, size difference is very less, so lattice energy is more. Highest lattice energy is LiF. Now coming to fourth question. Which one of the alkali metals forms only the normal oxide M2O on heating in air? Lithium, sodium, potassium, rubidium, cesium. So lithium can form only oxides. Sodium can form peroxide. Potassium, rubidium, cesium can form superoxides. So lithium does not form any peroxides and superoxides. Lithium only form monoxides, that is Li2O. So that is the formula for M2O. So answer is lithium. Coming to next question. A few grams of sodium carbonate is added to 1 liter of water. Now what is the pH or pH range of? Now sodium carbonate, it is a salt of strong base and weak acid. That means sodium hydroxide plus weak acid, carbonic acid. If any salt is formed from strong base and weak acid, thus the nature of that salt is basic nature. Because the base is strong, that's why the salt gets basic nature. For basic nature, pH always in the range of 7 to 14. The answer is 7 to 14. Answer A. Coming to next question. Observe the following reaction. MCl2 given MCl2 at 1200 Kelvin it exists as a linear monomer. In vapor phase it exists as a dimer. So what is the M? Is it CaCl2, SrCl2, MgCl2, BeCl2? Absolutely, that is BeCl2. So because in BeCl2 at 1200 Kelvin it exists as a monomer. And in vapor phase it exists as a dimer. it exists as a dimer. In vapor phase it exists as a dimer, and in solid phase or salt state, in salt state it exists as a polymer. It exists as a polymer. It exists as a polymer. So the answer is BeCl2. So BeCl2 in vapor phase it exists as a dimer, in solid phase it exists as a polymer. At 1200 Kelvin it exists as a linear monomer. Now coming to question number 7. Which of the following is known as fusion mixture? Which of the following is known as fusion mixture? The mixture of potassium carbonate and sodium carbonate always known as fusion mixture. It is used for qualitative test for organic compounds. Qualitative test for organic compounds. So fusion mixture. What is fusion mixture? It is a mixture of potassium carbonate and sodium carbonate is called qualitative. That is fusion mixture. It is used for qualitative test for organic compounds. Now coming to 8th question. In Kastner-Kellner process, in Kastner-Kellner cell, for the production of sodium hydroxide, in Kastner-Kellner process, sodium hydroxide is prepared. This is one of the electrolytic process. In this electrolytic process, take the electrolytic cell and the electrolyte is a brine solution. That is aqueous solution of sodium chloride. Aqueous solution of sodium chloride also called brine solution. Now they take two electrodes. One is cathode and one is anode. Mercury used as a cathode. And graphite used as a anode. During electrolysis process, so this is sodium chloride. During electrolysis process, sodium combines with mercury cathode. And form sodium amalgam. It forms sodium amalgam. Sodium amalgam further treated with water, so we get sodium hydroxide, hydrogen and mercury. So the correct option is, what is the correct option? Brine is electrolyzed with platinum electrodes. That is wrong. Brine is electrolyzed using graphite electrodes. That is wrong. So along with graphite electrodes we use a mercury cathode. Molten sodium chloride is electrolyzed. That is, we should not take molten sodium chloride. We should take always aqueous solution of sodium chloride. Sodium amalgam is formed at mercury cathode. That is right. Coming to question number 9. Which of the following is not correct? The hydration enthalpies of alkali metal ions decreases down the group. Lithium, sodium, potassium, rubidium, cesium. So when we are moving down, the size of the ions increases. So hydration enthalpies also decreases. So first one right. And lithium halides are somewhat covalent nature. So lithium always shows anomalous properties. That's why it can show covalent nature. Remaining all ionic nature. That is right. Second one is right. Next, alkali metals react with water, liberate oxygen gas. These alkali metals react with water. For example, take sodium and react with water. It can produce H2O means H plus and OH minus. Na combines with OH, it forms sodium hydroxide, and H plus converts into hydrogen gas. So in alkali metals reacts with water, it produces hydrogen gas, not oxygen gas. This is wrong. KOT is paramagnetic. Yes, KOT is a paramagnetic because it contains O2 negative charge. That means it contains 17 electrons. If any space contains odd number of electrons, that is paramagnetic. That is a correct statement. Next, coming to alkali metals are powerful reducing agents because so reducing nature depends on ionization energy. So reducing nature inversely proportional to ionization energy. If the ionization energy is more, reducing nature is less. If the ionization is very less, reducing nature is more. First A group elements exhibits alkyl metals are first A group elements always can show low ionization energies. Low ionization energy. The low ionization energy, that is more reducing nature. That's why their ionization energy is very less. Alkyl metals have low ionization energy. That's why this can show more reducing nature. Thanks to all for watching my video.